episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. So before we get into the what nerdy stuff have I been up to this week portion of the show, we gotta talk about GitLab again. So if you're unfamiliar with the whole GitLab saga, we covered it in last week's episode of the Dark Assassins podcast, so I encourage you after this to go listen to that. In addition to that, we talked about some other good topics, about some sarcasm with antivirus, and just diving into multiprocessing and multi-threading and how that works. So definitely a good episode. If you haven't listened to it, highly recommend going over to listen to that after this. But the TLDR of the whole GitLab situation was, just as a recap here, GitLab, it was leaked to the register that GitLab was planning to delete quote-unquote dormant Git repos from those in the free tier. And basically what that means is anyone that is not a paying subscriber to GitLab, they had a repo on their GitLab account that hadn't had any comments, any code pushes, any merge requests, issues, any kind of activity whatsoever, that account or that repo would be considered dormant and then would be deleted after 12 months. So you can hear my full analysis and kind of things I thought that they should do and why I didn't like that situation in the previous episode. But GitLab responded. The funny thing is, depending on when you listen to that last episode, there's a chance that GitLab might have already responded by the time that you listen to it, because I recorded that, I believe it was on Thursday, and then it got published on Saturday, but I believe GitLab responded that Friday, I think. So we're going to kind of go into GitLab's response here, but it was kind of funny because apparently this whole situation, as you can imagine, kind of went viral, especially amongst developers, because this is a pretty big deal, right? You float around the idea that a bunch of developers' code's going to get deleted, and developers aren't going to be very happy with you. So it kind of blew up, and GitLab was kind of forced to respond to it. And their response was that they were no longer going to be deleting accounts, which is fantastic. This was the tweet that they shared. We discussed internally what to do with inactive repositories. We've reached a decision to move unused repositories into object storage. Once implemented, they will still be accessible, but take a bit longer to access after a long period of inactivity. Which, if you remember from the episode last week, I mentioned a similar solution to this, something along those lines, moving it into more of a bulk storage where it might take a little bit longer to access, but it's not deleted. And it seems that's what GitLab ended up deciding to do. So if you're interested in reading the whole article, the Register posted an update. I'll have that linked in the show notes below if you care to go give that a read. But yeah, I guess the leak that we were kind of speculating on last week actually ended up turning out to be true. And GitLab responded. Kudos to them. I guess it is kind of a bummer that if that was even on the table, I think, to potentially delete people's repos. I think even that being on the table in general is definitely not a good move. But I do gotta give them props, give them credit where credit is due. They didn't end up going that route, and your repos are going to be safe. So you don't have to worry about that. But this is a pretty good segue into what nerdy stuff have I been up to this week, because I mentioned in last week's episode that if this ended up being true, that I would stand up my own Git repo in my home lab, and I could just push all my code there. So I ended up doing that, but because I've been busy doing other things, I actually haven't had a chance to push any code to it. But I did stand up a repo. I got a Git repo set up. Everything's good to go. All it's waiting on is me to create some repositories on there and start pushing code. So that was a big win. Of course, it happens after this news that my repos actually aren't going to be deleted. But I think just in general, I've gotten this far. I might as well, continue and go all in and, push to those repos also. What I really want to do is kind of use this as a learning experience and try to see how it works pushing to multiple repos rather than just to one, since if my repos aren't going to be deleted on GitLab, there's really not much point in deleting that account, or at least deleting those repos. Might as well just keep them up there, but kind of have a secondary repo for that code in my private repo in my home lab, and maybe I could add some additional things to there and some more private repos that I want to add, personal config files and that kind of thing. So that will be definitely awesome. So now getting into just the other nerdy stuff I did this week, I think I mentioned that I was getting a new server in and getting all the parts in for that. But anyway, at the end of last week, they did show up. I put the server together. It works great. It is a little louder than I would have liked. I'm still going to try to play around with and tweak the fan curve a little bit on it, see if I can't try to quiet it down a little bit. Although I will be interested to see come the winter time, once things get cold again and it's not hot, to see how it fares then, because obviously then the ambient temperature is going to be much lower and it'll be a lot better for cooling and whatnot, so it might not be as loud over the winter, but we'll see what happens. But I have to admit that I am an idiot. In case you did not know, I am actually a pretty large idiot, as it turns out, because I do not know how to configure a RAID array correctly, apparently. And if you're not familiar with what a RAID array is, we'll get into it more later on in this episode of what RAID is and that kind of thing. But the quick version of it right now is it's basically a way that you can kind of join drives together to basically look like one drive. So for example, you could if you had 3 1 terabyte drives, you could put them in a RAID array, and you could, depending on which version of RAID you used, you could end up with, say, if you in this 3 1 terabyte drive example, you can end up with 3 terabytes. You could end up with 2 terabytes or one. Yeah, usually I think with 3 drives you could only have. You're limited when it comes to RAID. You're kind of limited on the number of drives and the kind of RAID that you use. But you could have one, I guess technically one if you really wanted to. But more realistically, you'd have either 3 terabytes or 2 terabytes, and that would basically just show up to any kind of operating system as just one drive. So that's kind of how RAID works. But I obviously don't know how to use it because I messed up when I made my RAID array. So I had 4 drives in this server. Each of them were 500 gigs, so I had a total of 2 terabytes total. And I was going to use that for my VM storage, and I was going to use Proxmox, and Proxmox uses ZFS, ZFS is just a different kind of file system. And ZFS has basically RAID built into it, so you don't need a dedicated RAID card or anything, which is nice. So the terminology between RAID, as in hardware RAID, and ZFS RAID is a little bit different, but as far as the RAIDs are concerned, they're basically more or less the same. You might get some people that are going to be really stingy and be like, oh, they're different. It's yeah, but at the core, they're more or less the same. But that's besides the point. So anyway, I was trying to set up a RAID Z1, which is the equivalent of a RAID 5, which basically means I have one drive of parity and the rest of the drives can be written to. And what that essentially means is I can lose a drive and I wouldn't have to worry about any of my data being destroyed or lost or anything like that. But what I did was I created a RAID Z2, which instead of having one parity drive, as you can maybe infer with the Z2 rather than Z1, RAID Z2, which I believe is more or less equivalent to a RAID 6, you have two parity drives rather than one parity drive. So in this case, you could lose two drives to drive failure or whatever, and your data would still be intact. Which is nice if you really care about, your data and making sure it's secure and all that. But when you're in my case and you kind of want a lot of storage and you're trying to upgrade from what you already had, which was a terabyte, going from 1 terabyte to 1 terabyte because you have 1 terabyte for the whole parity rather than just 500 gigs, you're kind of missing out on part of the problem, or part of the solution that you're trying to implement. But it gets worse than that, because not only did I mess up the RAID array like an idiot, I also migrated all my VMs to this drive before I realized that I messed it up. So now you might understand how, the scale of idiocy that comes here. So I transfer, it wasn't quite a terabyte worth of VMs, but it was probably around like 800 gigs or so worth of VM disks over to this new server. And then I was looking at how much size I had left, and I was like, wait a minute, why do I have why do I have such little space left? I should have like 1.5 terabytes. Why is this so small? And then I was looking in and I was like, oh, wow, I did a RAID Z2, not a RAID Z1. I'm an idiot. So then what I had to do, in order to reconfigure the RAID array, I had to move all of those VMs that I just copied back to the original server, reconfigure the RAID array the right way to a RAID Z1, and then copy all the VMs back to the server. So rather than just doing the migration once, I had to do it 3 times, which, yeah, it makes me kind of seem like an idiot. But I swear, I am an idiot. But I guess it's, learning experience, I guess you could say, looking on the bright side of things. But the one nice thing I will say is it wasn't like occupied time, right? Because when you're migrating a VM like that, you can pretty much, it's like copying a file, essentially. You can pretty much just hit migrate, and then you go off and do something else while that does its thing. You don't have to like actually sit there at the keyboard and, typing away and doing things and it being active time. You don't have to worry about that. So in that sense, it wasn't as bad as it could have been, but at the same time, it took like an extra half day or something like that or more to get all that configured the right way because I messed it up. And going back to it's kind of unoccupied time, literally when the last VM was starting its migration process, I was like, you know what? I am migrating this VM and I am going to bed. So I just let it run overnight. Obviously, it didn't take all night to finish that, but And then the next day, when I was migrating, after I reconfigured the RAID array and was migrating the VMs back to their new home on the new server, started that migration process. I was like, you know what? I'm going to do some cleaning. So I went, did some cleaning, and yeah, when I was done cleaning, the VMs were migrating. I was like, cool. Finally where we should have been yesterday at this time. Nice. Which I guess it would have been a little earlier than that time yesterday, but, that's besides the point. Regardless, it should have been done, on the Saturday, ended up being done on the Sunday. Oh, well. But that's not the end of where the nerdiness ends, because all I do is nerdy things. So what I also did was I was doing some research into how to quiet Dell R510 fans. So I have a Dell R510 PowerEdge, which is a 2U server. It has 12 hard drive bays in the front, which I basically use it for my NAS, network attached storage. I don't have all 12 drives populated. Maybe down the line I'll get there, but as of right now, I don't have all 12 drives populated. But it's nice for expandability, so if I want to add more drives, I can easily plug more in. But the reason why I never have that server turned on is because it's just loud. And for no reason. I'll check the temperatures on it, and this thing's running at 20 to 30 degrees C. Usually it was in the mid to high 20s degrees C, which is chilly for a CPU. If you know anything about CPUs and the temperatures they run, usually if you're running 40 to 50, that's kind of normal, not too bad. And then when you really get hot, you're looking at 80s, maybe 90s if you're really cooking. But in the 20s, that's getting that's obviously warmer than ambient, but not by much. So, but even with that, this thing was roaring its fans at over 3,000 RPM, and I'm like, why are you doing this? You're not hot. Chill out, dog. So I was doing some research, and I found this fantastic script on GitHub, which allows you to quiet the Dell fans on Dell servers with iDRAC and IPMI and all that good stuff. So that's what I did. I configured it. How it works is IPMI is basically is essentially think of it as if iDRAC is the web console that you can manage the server remotely. IPMI is essentially the command line version of that, except IPMI is a actual standard, it's a broad standard that's used across all server manufacturers from Dell, HP, Intel, IBM. It's a standard across. It's compared to iDRAC, which is a proprietary Dell thing. But iDRAC and all those remote management softwares are built on top of the IPMI. So basically, what this script does is it takes the temperature of the server, checks the temperature, and then if depending on what its temperature is, it'll send a command through IPMI to the server to tell it what fan speed to run at. Which is pretty cool, actually. And it's the nice thing about this script is it's it's configured in a way where if it gets to a certain temperature threshold that your fan curve can't cool, it'll just send the control back to the regular iDRAC IPMI stuff, and it'll go ham and make it roar like crazy and cool it down. And then once it's cool again, it'll take back over control and quiet the fans down. So now it's at the point where this thing is running almost silent. So I was able to take the fan speed down from over 3,000 RPM to under 2,000 RPM. I think it's running at 1,800 or something like that. And it's still running in the low 30s as far as degrees C is concerned, which is still pretty chilly. So if I wanted to, I could probably drop the fan speed even more if I wanted. But I mean, it's already pretty much, inaudible, at least when it's in a rack of other servers. It's kind of blends into the sound of the faint hums of all the other servers, whereas before it was the clear loud one. So that is nice that it's the quiet, it's more on par and more quiet, so now I can actually keep it running and actually have a NAS that I don't have to be I want to put something on my NAS but it's powered off, so I have to power it on and go through all that mess. But now since it's just on, it's great. And the other benefit is the power draw dropped fairly, I don't know about significantly, but it dropped a noticeable amount, which it's kind of crazy if you deal with enterprise servers at all. It's really kind of insane how much power the fans use. Like, you drop how much the fans are spinning, and it's insane how much your power draw at idle is. Like, I believe it was drawing, I want to say it was in like the 160s or like 170s or something when it was running the fans higher. And now when I drop the fan speed down to what it is now, it's running at like, it's only using like 100 and it's not even using 130 watts at idle, whereas before it was using like, what was that, like at least, like it was using like, 170, 180, I think, somewhere around there. So like, I mean, that's a pretty decent amount of wattage drop just from reducing the fan speed. So if you're worried about your power bill and you're running enterprise servers, try to look at those fan curves and see if you can't bring the fan speeds down a little bit, and that might help your electric bill at the end of the month. But since we're talking about, this, my Dell R510 here, using my NAS, that kind of brings up the main point that I wanted to talk about in this podcast, which is how should you back up your data? So in an ideal world, I believe I've talked about this on the podcast before, but the ideal backup situation is a 3-2-1 backup. And what that means is you have 3 different backups, or you have 3 different copies of the data that you're trying to, store or whatever. And it goes back to this philosophy of 1 is none, 2 is 1, and 3 is 2, which might sound a little weird, but if let's walk through it here. So if you have 1 copy of the data, you essentially have 0 copies of the data. You have no redundancy. So if you say you have, let's just assume it's your resume, right? So if you have your resume on your computer and your hard drive or your SSD or whatever your drive is dies or, gets destroyed or whatever, or your computer gets destroyed, your resume's gone, right? So then that's where the idea of 2 is 1, because if you had a backup of that, say on a flash drive or something, even if your computer was destroyed, you'd still have it backed up on that flash drive and you'd be fine. But this is kind of more of an apocalyptic view. But if, say, you have your computer and your flash drive at your house and like something bad happens to your house, like a flood or a fire or something, and your computer and your flash drive are destroyed, well, then you don't have your data anymore. So then the third level of the backup is an off-site backup. So whether that's, an external hard drive at your friend's house, whether that's some cloud service like Google Drive or iCloud Drive or Dropbox, OneDrive, any of those other drives in the cloud, whether it's something like that, or you're just storing a drive at work or at a friend's house, or if you're going real ham, you have an actual server in one of those co-location data centers that you can rent, which actually that's actually a real thing. So what you can do is you can like rent space in like an actual data center and like put your server inside of an actual data center, which is kind of cool. The only problem with that is I haven't done it, but from the little bit that I looked into it, it looks pretty expensive for what you're getting. Like, you have to pay like essentially a reservation fee to reserve the space, which isn't necessarily that cheap. And then you also have to pay for like all the bandwidth and the power. There might have been like something else too, but like you have to pay that additionally. So it ain't cheap to host, put your server in like a data center like that. I mean, the idea, don't get me wrong, is super cool. And like that would be like the dream, off-site backup solution, right? You have your server running in a data center. and full hardcore gamer mode. Not really, but that's like the full hard on core hardcore situation where you have your server like actually in a data center and all that. But that's not exactly cheap. But the problem in general with the offsite backups is none of them are really that cheap, or that what's the word? They're not necessarily, one, they're not cheap, and two, they're not that practical depending on what you're dealing with. So let's take the example of you just store a hard drive or something, an external hard drive at like a friend's house. I mean, it's great, but how often can you actually update that backup, right? Like, you're either only going to be able to do it when you go over to your friend's house, or have them bring the drive over to you, you update it, and you send it back with them. Like, it's just kind of inconvenient. And then if you're dealing with either hosting your own server in a data center, like, because you want to be cool, or if you're just average Joe Schmo and you use some kind of cloud solution like a Google Drive or iCloud Drive or OneDrive, or any of those, you're limited on your upload and download speed, right? So if your internet speed is garbage, if you live out in the middle of nowhere with like DSL, satellite internet, good luck backing up your data, because most people don't just have, a few documents and that's it, right? Most people have, family photos and home videos and, I don't know, a bunch of other things that they have backed up. Maybe they have some games. Maybe they have, kids, like, school projects or something backed up. I don't know. But you got tons of stuff, right? So trying to upload all that into the cloud, depending on what your upload speed is, which for most people is significantly lower than what their download speed is, it's going to take a long time. And that's not to mention the fact that even your download speed, most likely, unless you're, some bougie kid that is able to get gigabit down because either you live in a highly populated area, or you're just, happy to blow a ton of money, which, don't get me wrong, I would love to have gigabit internet download, and for that matter, upload, but I ain't paying that kind of money. So if you have like a locally hosted thing, like say a locally hosted NAS or something, I mean, the sky is kind of the limit. Well, I mean, you obviously have, it comes down to what you're willing to spend on your networking solution. But the sky is kind of the limit as far as speed goes, because if you're using, a RAID system, you can join drives together, which can increase the overall speed of those drives, so you can achieve even higher speeds than just, one drive by itself. So if we're talking about, going back to the hard drives, if you put a bunch of hard drives in a RAID array, like, one hard drive by itself isn't that fast, but if you can link a bunch of hard drives together, and rather than it reading from one drive, it's reading from, say, like 4 drives all at the same time, and that data is spread across those all those 4 drives, you're basically getting, a 4 times increase in speed. So you definitely get some pretty quick speed ups. So if you invest in, like, if you just get, like, say, a gigabit switch, like, that in itself is gonna, give you pretty decent download and upload speeds, like, just as around your internal network, which would be more than likely, unless you have gigabit upload and download, because you're, way better than everyone. Unless you have that, that's gonna beat a cloud solution any day of the week, and it's not even close. And, that's pretty cheap to do. Like, gigabit switches aren't, one, they're not that expensive, and two, you wouldn't even need a gigabit switch. You could literally just connect 2 computers' Ethernet ports together and you're good to go. Because unless you have, like, some computer from, over 20 years ago that you're trying to network or something, and even that, depending on the model, might even have gigabit internet, but almost every modern computer that has an Ethernet port is at least gigabit. So you got some pretty fast speeds there. And then if you want to go even fancier, you could upgrade to like 10 gig Ethernet, which I've wanted to get into the 10 gig game for a while. I'm not going to lie. But 10 gig switches aren't exactly cheap. Like you can find some that are like under 300, I think, but like you're not necessarily getting a ton of ports, and I don't know. And the other thing with 10 gig too is usually it's, well, especially on like the cheaper versions, it's like roped in with gigabit switches. So let's say you'll have like 8 1 gigabit Ethernet ports and then like 4 10 gig ports or something like that. So finding just like a sole 10 gig only for not a ton of money is still kind of hard to find these days. But that's not to say you couldn't just, buy some 10 gigabit PCI cards and throw them in some computers and link them up that way. You could definitely do that, and that would totally work. And that would give you some nice 10 gig. The only problem with that is you're kind of limited on, how many, devices you can connect together if you don't have like a centralized switch that you can plug things into. Which I guess that whole topic of network switches and how that works, that's kind of would be its own discussion. But focusing on like the backing up of your data, I think definitely, having some kind of backup is better than none. But the one issue that I have with cloud backups is, while they're great for that offsite backup, for that third stage of the 3-2-1 backup, the issues that I have is, one, you have the speed issue. You're limited on how quickly you can upload and download, and you're also limited on how much stuff you can actually put on those. And depending on how much storage you're getting, you're still going to be paying a decent amount for it. And you might think like, yeah, but I'd rather, it's not like it's, not a ton of money every month. So it's not that big of a deal. And, if I went out and like bought all the hardware and all the hard drives to make a NAS, that would be even more money. Which, yes, you're right. It is a more upfront cost to either build your own NAS or buy a NAS. But at the same time, it's kind of that mentality of buy once, cry once. Because once you have the hardware, you're set. You don't have to worry about it. You don't have to pay. The only monthly expense you're paying is the electric bill for it. And depending on what kind of hardware you have and how much you use it, that electric bill would most likely probably be cheaper than your cloud subscription, especially for the terabyte. If you're talking about like, a NAS that you make with, say, 10 terabytes, how much would it cost you to get 10 terabytes in like, I don't even think most cloud providers even offer that much storage. If you wanted that much storage, you'd have to get some like, specialty deal or something, like, and actually contact them and like negotiate. Like, maybe I've seen 5. I know I've definitely seen 2, but even though like those are not cheap, when you're getting like, 2 terabytes, that ain't cheap. But running a server like with, 10 terabytes, say, unless you're like doing a bunch of other stuff with it, which you definitely could do, your electric bill would probably be cheaper than, actually paying for any kind of cloud subscription with that much storage. So yes, it's buy once, cry once. It is an upfront cost that would be, depending on how ham you're going, quite substantial. Don't get me wrong. The sky's the limit on these NASs, especially if you're going with like a pre-built solution, like a Synology box, for example. those things are mad expensive. But if you go the route like I did and you buy an old enterprise server with a bunch of empty hard drive bays that you can, expand as you want and, put whatever drives you want in, which for the record, you can do that with the Synology too. You can put whatever drives you want in there. But as far as like expandability, the more drives you get on a Synology box, the more expensive they get, and they get pretty expensive pretty quickly. But if you're going with you're building your own essentially, yeah, it's a lot more work up front. Like you actually have to configure everything, install an operating system, configure your drives and that kind of thing. But it's a lot cheaper than, actually building or buying a pre-built NAS. But the nice thing about the pre-built NAS is if you're a beginner and you don't have much experience, it's pretty much just plug and play. You pretty much put your drives in and you're done. You don't have to worry about anything else. But if you like tinkering and you're a home labber, buying an old enterprise server and throwing your own drives in there is definitely the way to go. It's also a lot cheaper. So you'll get your return on it, your ROI, your return on investment a lot quicker than if you went with like a Synology or something. But even still, even if you went with say a Synology, and you had your own NAS, while it might take a little bit, you'd get your return probably a lot quicker than you might think. Especially depending on how much storage you're paying for with the cloud provider. And the other problem I have with the cloud providers is since your data is on their servers, you have no idea if your data is actually safe and secure. You have no way to know if they're snooping on you or if they're looking at what you upload on there. You don't know. Now, realistically, do I think they're probably looking at your stuff? I think in most cases, probably not. In Google, I'm not so sure. But the easiest way around that would be if you wanted to use a cloud solution, say as your third stage of the backup, what you could do is you could just encrypt everything and put the encrypted data up on the on your cloud storage, because then it doesn't matter if the cloud provider's snooping on your data or not, because it's encrypted, and as long as you have the key and the key isn't anywhere on the server there, they can't decrypt your data and you're safe and you're fine. So if you are going to use a cloud solution, if you want the most amount of security and to ensure that your data is not going to be looked at, I would highly encourage you look about encrypting that data before you upload it to any kind of cloud provider. But I also mentioned earlier in this podcast talking about RAID, and I want to talk about RAID in the last few minutes here before we wrap this up. So there's a couple different types of RAID. There's hardware RAID, which is an actual card that handles all the RAID controlling, and then you have software RAID like ZFS that has some RAID capabilities. So the fastest, most performant type of RAID would be a striped RAID or RAID 0. Now, this is, if you want maximum performance, this is the way to go. So if you have, say, 4 1 terabyte hard drives, if you made them into a RAID 0, it would essentially, to the operating system, look like one singular 4 terabyte drive. And it would be a lot quicker than all those 4 drives individually. It'd be a lot quicker since you can you're basically pulled them together and you're striping the data, meaning you're writing the data across all the drives and reading across all the drives. So you have a really great speed increase here. The problem with RAID 0 is there is no fault tolerance. So if one drive goes down, all your data is gone. So this is definitely not the way you want to set a NAS up unless you have a really, really good backup solution for your backup solution. Which, ironically, if you really want to make sure your data is secure, however balls out you go on your backup solution, you have to go equally balls out on a backup solution for your backup solution to make sure that your data is really secure. So it is what it is. But RAID 0, if you have that in a NAS and that's your backup, and for whatever reason one of those drives fails, all your data is gone. And that's really going to stink, especially if you have like a massive, pool or massive array. And so you have like 12 drives in a RAID 0, and you got like, I don't know, 72 terabytes worth of raw storage there. One drive goes down, all of it's gone. Rip you. Don't be that guy. But RAID 0 is, it's really good if you don't necessarily care about the data's integrity, or you're like backing it up on a regular basis. So if you did lose the data, it's not that big of a deal because you can easily get it back. But RAID 0 is definitely the way to go if you need performance. And then we have RAID 1, which is essentially a mirror. And what that is say you have 2 drives, say each of them are a terabyte. To the operating system, it only shows up as a single 1 terabyte drive. So, but how the RAID 1 works, or how the mirror works, is kind of what it sounds like, a mirror, right? So in ZFS, I believe it's called a mirror. Hardware RAID-wise, it's RAID 1. And what this means is you're writing the same data to both drives. So you don't get any kind of speed increase from this. You don't get any kind of performance increase at all. But the really good thing is if you really care about data integrity, one drive could completely die and you still have another copy of that data saved, so you don't necessarily have to worry. So that is the good thing about mirrors and RAID 1, but you're not getting any kind of improved performance out of it. And then we get into kind of the mix between those two, which is the RAID 5 and the RAID 6, or the RAID Z1 and Z2. And what this is kind of, as I mentioned before earlier in the episode. So RAID 5, you need at least 3 drives for this. You would have 2 drives that would essentially act as your storage. So going back to the 1 terabyte example for easy numbers, if you had 3 1 terabyte drives, to the operating system, it would look like a 2 terabyte drive, and you could lose one of those drives and all your data would still be intact. Now, how does that work, right? You lose a drive, how is your data still intact? So what you can do is, how RAID is designed, you could swap out the dead drive, put in a new drive, and then because of how the parity works, it can essentially reconstruct the data that was quote-unquote lost on that drive that died and failed. Now, don't get me wrong, it's not necessarily an easy process. It's going to take a while, but you can recover your data. But I also should mention, RAID is not a backup. So if your backup solution is a RAID, you're doing it wrong. Although, in fairness to you, a lot of people are guilty of this. I guess I would kind of say myself included. But you should not be relying on RAID as a backup, although it can help prevent data loss in the event a drive fails. So unlike RAID 0, where if a drive fails, you're out of luck, all your data's gone, the nice thing about RAID Z1 and RAID 5, even if you lose a drive, you can put in a fresh, good drive and reconstruct the data, and you don't have to worry about losing anything. And then we get on to RAID Z2 and RAID 6, which kind of takes us a step further and adds a second level of fault tolerance. So you could lose one drive, don't have to worry about it. You could lose 2 drives, and you're still fine. Just swap out those dead drives with 2 good drives, and you can reconstruct the data and none of your data is lost. No big deal. But again, if you have to go through the process of reconstructing an array of drives, especially if you got a ton of data, like if you got like terabytes worth of data and you have a drive fail, it's probably going to take a good while to be able to rebuild that array. But on the bright side, your data should still be intact. And then there's other forms of RAID. There's like RAID 50 and RAID 60 and RAID 10, which is basically a combination of the two and kind of takes inspiration from different kinds of RAID and kind of merges them into one. So like, for example, RAID 10 is essentially a combination of RAID 0 and RAID 1. So I believe it's you take 4 drives and you basically have a striped across those 4 drives, but each of those 4 drives are kind of grouped into 2s, and each one of those 2s is mirrored. So it's kind of the combination of RAID 1 and RAID 0. And then RAID 50 is essentially the same thing except with RAID 5. And then RAID 60, the same thing, but with RAID 6. So you can, it kind of depends on how many drives. So basically how you can think of RAID and which RAID you should go with kind of depends on your use case and how many drives you have. So say if you only have 2 drives, then you can't really use a RAID 5 or a RAID 6 because you don't have enough drives. So you could, then if you only had 2 drives, it comes down to, do I want the most amount of storage, or do I want to make sure that I can survive a drive failure? If all you care about is speed, then RAID 0 is your way to go. If you want to make sure that you're safe in the event of a drive failure, then obviously RAID 1's how you want to go. So it definitely kind of depends on the use case. Personally, I really like RAID 5. And RAID Z1, mainly because you have some security in the fact that you could lose a drive and you don't necessarily have to worry about your data being lost, but at the same time you don't need to go out and buy a ton of drives because depending on how big your drives are, that can be kind of expensive. So only having to need like 3 drives at a minimum for RAID 5 to work is definitely a nice add-on. But if you had a larger number of drives, like, say a 12 drive array, for example, then maybe you kind of want to go with like a RAID 6 approach, because then you have some extra assurance that if you could lose up to 2 drives rather than just 1. So obviously, like, I guess you could think of it, if you have a ton of drives, you kind of want to think more into having, more drives worth of, fault tolerance. It's not necessarily a good thing if you have, say, if you're, like have a massive storinator or something that has like a, like I know there's some like 45 drive, storinators or whatever. If you're have that fully populated with 45 drives and you have, like a RAID 5 and you have 1 drive for parity, if that drive goes down, rebuilding an array, it definitely kind of can take its toll on drives. So if you're kind of rebuilding a massive array like that, you might lose another drive in the rebuilding process, and at that point your data is gone. So if you have a really large array, you probably want to make sure you have more parity drives that can be used, so you can increase your fault tolerance. So the thing with RAID, at the end of the day, there's no one solution that's the best, RAID solution. It really depends on how many drives you have, what kind of performance you're looking for, and what kind of fault tolerance or parity that you want to achieve. So yeah, that's RAID. Hope you learned something. Hopefully I explained that well for you. But I think that's going to do it. So if you enjoyed this episode, I ask that you please leave a rating and review and subscribe to the Dark Assassins podcast if you haven't done so already. On either Spotify or the Apple Podcast app. Also be sure to share with a friend or family member who you think would be interested in learning about backups and RAID and storage and the nerdy things that I do, or how I was an idiot, or if you told them about GitLab last week and let them know about the update. If you have any questions, leave it in a rating and review, or you can shoot me an email at contact@darkassassinsinc.com. There's a link in the show notes below that you can just click on. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.